Hello my friends, welcome to our new CCNA lab video about two popular dynamic routing protocols, RIP and EIGRP. Just a little note here, EIGRP and RIP are out of CCNA topics generally, and a headline protocol topic is only OSPF for now, but it is always good to know some fundamentals. That will also help you with your configuration about OSPF setups. Before we get started, let's take a moment to understand what these protocols are all about. First, we have RIP, which stands for Routing Information Protocol. RIP is a distance vector algorithm that uses to exchange routing information between the routers. It is simple to set up and configure and widely supported across different network devices. In our lab, we will be using RIP version 2 between routers 1 and 2 and allow them to exchange routing information seamlessly. Next, we have EIGRP. First, there was an IGRP, and now we have EIGRP, which is Enhanced Interior Gateway Routing Protocol. EIGRP is also distance vector algorithm, but with a twist. It's a Cisco proprietary protocol actually. It works on Cisco devices. In our lab, each router will be running EIGRP, but routers 2 and 3 will have different AS numbers, autonomous system numbers, which will prevent them reaching to other routers with different AS numbers. Some of them will be having two EIGRP with different AS numbers defined on the same router. This setup will allow us to explore the nuances of EIGRP in practical testing. Now let's talk about the lab itself a little bit. At first, sorry from all of you, but I need to take this video more than a few days, so if some things get a little bit hard to understood, you can always come back here in this time of the record to check everything. So the idea is to implement the EIGRP and RIP protocols and how they work. VLAN and IP addresses of the networks is described on the picture. It is the same as what has happened in the previous labs. Between the routers, I define the network addresses /29 because it would be easier if I choose 20/30. It should be the only addresses they can take was 1 and 2, but by doing so like this, you can put the last digit of the IP address as 1, 2, 3, 4. So because of that, it's chosen as /29. I'm always choosing G02 as a sub interface that's going to the switches. So we will start the lab by setuping the switch, access and trunk ports. Then we will go into the routers and we will define the DHCP excluded addresses, DHCP pools, and the sub interfaces related with the switch. And then we will put the IP addresses for related G00 and G01. When everything is finished, I will not show every setup of all routers. I will only show one or two, so you can copy and paste the TXT files or play with it or do by yourself manually the other routers. And in the end, we will first implement the RIP between the two routers. Then we will do EIGRP with only one AS number to see everything is seen, and it will go right over the RIP protocol because it has less administrative distance. And then we will put EIGRP 200. Actually, we will change the present EIGRP 100 AS number to 200. So we will see some connection will be lost because of the different AS number. Then we will add another E200 to R4. and we will check the connections. You can play with it by putting different AS numbers to see what is happening in the end. Okay, so we can start. Again, we will start with switch setup. I'll take the host name, enable config terminal, host name, switch 10 and 20. And then I will choose the interface range, all from 1 to 20. Switch port mode access. And switch port access all access VLAN 10. Then I will choose from 11 to 20 and I will make it VLAN 20. Then I will define G02 switch port mode trunk and I will allow 10 and 20 in this trunk interface. And I will copy it into the startup config. I hover it and you can see all is set. I can also check the track interfaces. It doesn't come probably because of the router interface is not set up yet. Let's continue with 3040. Same setup. Host name. All right. Yes. And interface range F0 to 20, switch port mode access. First VLAN 34. Sorry. I will put 30 only. Then change the range from 11 to 20 and 40. Okay, this is 30 and 40. We will define the trunk. Switch port trunk allowed VLAN 30 and 40 only. Okay. I'll copy the name. Interface range F0 1 to 20. Switch port mode access VLAN 50, 11 20 and 60. G02 is defined as trunk for 50 and 60. Okay. Same setup. It looks like boring, but it is good to do some practice. So we'll get used to it. VLAN 70, 11 20, VLAN 80. G02, switch port mode trunk, allowed VLAN. Switch port trunk allowed VLAN 70 and 80. Right. And okay. Now is the router setup. First we will go to R10 and 20. I will copy the host name, enable, config T, host name, paste. Then I will go defining G02, no shutdown. I will define the sub interfaces for VLAN 10. encapsulation.1q. IP address will be added for default router 10.1/24. Then I will do it for 20 encapsulation, and the IP address will be 20.1. Then I will define the I cannot do here exit. IP DHCP excluded addresses will be defined, so PCs will not take it. 10.1 to 10.10, then 20.10, 20.1 to 20.10. Then I will define the first pool P10. Network will be 10.0.10.0/24. Default router is 10.1. Do the same for 20. Network will be 20.0. Default router will be 20.1. Okay, now go to PC. Check the IP address, try to get it, renew. Do the same for this one. 10.11, 10.12. This is the okay. It looks like interface problem. I will delete this and add any of the VLAN 20 interface starting from 11 to 20. I choose 11 here. Renew. Okay, 20.11. Now we will go to the 0.1 interface. 192.168. 2.1. This is router 1, so all the IP address last digit will end with 1. No shutdown. Then I go to G00. This will be 0.1. Okay. So when I do this, seems like 00 has problem. I do this no shutdown, so administratively down is cancelled. Copy this. Now export this as running config that we do in the earlier labs. This is my R1020 setup. Then you can go to your download, copy paste wherever it is, then change the name of this one 30 to 40. Then we change the related things, host name, excluded addresses 40, pool numbers and network and default router addresses. This will be 40. Then we go down for G0. Okay, look at the interfaces first. This is R2, so it will be sorry, this is R2, yeah, it will end with 2, all the last digits. So let's come here, 0.1. I arranged the interfaces like this so it's easier to change. You don't even play with the interface numbers, just change the digit number. This is 1, 2, this is 0, 2. This is 30. This is for, there's a mistake. This is second interface, so we don't change this one. We change the sub interface. 40. Then we'll go down. Seems like okay. Now we put it as startup config. Okay, then we will do enable and reload. Next. Let's check. Okay, router name change already. And we can copy this command, so we can use it all here also. And also check for the, okay, there's nothing administratively done, and 0212 is correct. Yes, 1212. Check the PC for the, okay, this is also wrong. I think I made a mistake in the interface of the switches, so it's better to delete all. When you connect the PC, first auto connect, it will connect it to the switch's first available port, which is 01, F01. So I will leave them as it is, but the others on the second VLAN, I start from 11 to 20. It can be anything. I choose 14, for example. Okay. Again, renew. Next. 30, good. This was already 40. Okay. When having the setup, I had an error in the R4, VLAN 70 and 80. I couldn't get the IP address automatically. So I checked that switch port trunk allowed VLAN 7080, but actually I didn't make it trunk. So you'll make it trunk and it will be fixed. Actually, this is like a troubleshooting for you. Okay. One more thing, I noticed that I didn't add loopback interfaces for the routers. It's easy. You just say go interface L0 and IP add /32. You can pause the video and check the recording here. Okay, now let's check the IP addresses of the PCs. It seems like okay. They have their IP addresses. Now we will define the RIP protocol between R1 and R2. As you can see, there's no routing protocol defined yet. We cannot see the PCs. So we will define with router RIP. I will use version 2 with no auto summary. When I do the network 000, it doesn't work. You will see it like that now. I will use 00 and then I will define passive interfaces. I will do the same for 30 and 40 now. Router RIP version 2, no auto summary. Normally in EIGRP and OSPF, when you choose like this, it selects all the interfaces present on the router, but RIP is not using wildcard, probably because of that it will not see the connections to the PCs. Okay, as you can see, 0000 doesn't work, so we will define all the network interfaces as it is. First, loopback interface 2222. Then the VLAN interface is 10.0. Here R230.0 then 40.0. You can also define both of them like 10.0.0.0, but do it like this now. Then define the other interface, G00 and G01. You can also define them as 00 for both of them. Then I will check the routing. Still it cannot be seen. If there is a way to restart it like we do in the OSPF, I want to clear the process, maybe because of that it's not seen. Let's exit here in the enable mode. There may be some. Okay, I cannot remember here actually, so let's check one more time. Okay, let's continue with the setup. We can reload the routers later. Router RIP network, loopback interface. This side I will define it, both of them, 10.00. The other one is the same. And then do show IP route. Still nothing seen. So I think it's better to delete the RIP protocols totally and start from the beginning. So config the no router RIP. This will delete all the previous setup. I will also do this here, no router RIP. Then I will define it from the beginning, router RIP. This time I need to add the versions again, no to summary. Then I will define network L0 VLANs and the G00 and G01 interfaces. Passive interfaces will be defined so these advertisements will not be sent through them. This side I will also define it. Version 2, no to summary. L0 is 111 here. Then VLAN, then the other interfaces I will define. And now we can check the RIP protocol and we can see that 30 to 40 and R2 is reached. The loopback interface is reached through RIP protocol. I forget to define passive interfaces on this one, so I will define them here also. Okay, again, it still continues. Okay, now we will start with the EIGRP setup. We will use the AS number as 100. So router EIGRP 100. We will define all the network interfaces. I don't want to waste time. By 0000, 255, 255, 255, 255. By the way, this is the wildcard. It's not subnet mask. Wildcard is, as you know, it is the opposite or complement of subnet mask. We can say it like that. Second router EIGRP, same as number 100. Network, all interfaces, and define the passive interface L0 and G02 here. When we check the routing protocols, as you can see, we can reach 1 and 3 loopback interfaces through EIGRP protocol, and there's nothing here. We will define the same here. All network interfaces and define passive interfaces as L0 and G02. Check the routing table now. Now we can see 3 routers, 1, 3, 4. One is connected, the other one is through EIGRP. And we also check here first. As you can see, there's only RIP protocol. to R1. Now again router EIGRP 100, then network 000, and passive interface will be also defined because this is EIGRP protocol, not RIP. We again define it here. When we check it, now all of them come, and as you see, RIP protocol is erased. We reach R1 through EIGRP 1111. Now write it, and we write this one also. We will do a little trick here. I will just export the running config of this one. Doesn't matter, and this is R100. I say it like that. AS number 100. So let's go to this one. I will also save it as 100. So I will change it to 200 later. Just to see that they will not see the 100 once. Okay, now let's go. First, this one. It's easy trick. We will just change the AS number here. Everything will be the same. And I will also do the same on this one. And then I will go to these routers. I will load them as startup config. First 70 and 80 I will choose. Okay. Then we will do reload as always, but no save here of course. And go to this one. Same thing, but I'll choose the R3040. And then reload. No. Fast forward. Now we can check the running config first. See, it's changed. Okay. Then I will check the routing table. You can pass it here if you want, but as you see, only the 30 and 40 I can reach from that one. And from this, when I check like that, I cannot see the 50 and 60 because it's 100. I see the others because I see R4 through 200, R1 through RIP. We can also check it here. It will see mostly everything, only 70 and 80 because it's just 200. R4 uses EIGRP 200. Now we will add the other routing protocols, but I don't know if you just copy paste. Do we need to leave a space or not? So let's do like that first. It will be easier. Config T router EIGRP 100 I will say. And when we check, yeah, it leaves a space normally. So when copying, we will use this format if you want to copy. But it's not too big problem, so I will just define it as it is. I will define the passive interfaces again. 0, 2, 0, 2. To show IP router, as you can see, all the PCs can be reached via EIGRP. And this one, it can also see, but only cannot see the 3040 yet. This one should have seen everything because it couldn't see 200 ones, R4, now it see them.